Okay, let's dive into this. Welcome to This Explainer. Today, we are embarking on a journey straight into the absolute core of Linux. Before we type a single command, let's establish what Linux actually is. Basically, it's the open source operating system that acts as the engine of our modern digital world. If you've ever wondered why Linux powers the vast majority of the internet's servers, smartphones, and global infrastructure, well, the answer lies right here: the command line. Today, we're going to master the Linux terminal, and it's going to completely transform how you interact with systems from the ground up. Here is our path to mastery for today. Number 1, welcome to the terminal. 2, navigating your file system. 3, reading and editing files. 4, taking system control. And finally, 5, advanced network diagnostics. We'll start by simply moving around, but very quickly, we'll be leveling up to analyzing raw network packets as our final boss. Section 1. Welcome to the terminal, your direct line of communication. Graphical user interfaces, or GUIs, are specifically designed to be user-friendly. But in doing that, they act as a filter that actually hides the true power of the operating system. In fact, most enterprise Linux servers don't even have a graphical interface installed at all just to save on memory. We're about to bypass that entirely. The terminal gives you direct, unfiltered, raw control over your machine. It's a completely unhindered way to speak directly to the Linux operating system, letting you pull off some incredibly complex tasks with just a few quick keystrokes. Section 2. Navigating your file system. Level 1. Moving around. To get comfortable here, I want you to imagine the Linux file system is like a massive physical office building. So how do we move through this office? Well, here's a real-world workflow for you. Step 1. When you wake up in the building, you need to know exactly which room you're in, right? You just type PWD, which stands for Print Working Directory, and it spits out your exact path. Step 2. Let's build a brand new filing cabinet right where we stand using mkdir, followed by the folder name. Step 3. We open that cabinet and step right inside, using cd, which changes our directory to that new folder. And finally, Step 4. We create a brand new, empty piece of paper in that cabinet using touchfile.txt. Boom! Just like that, you've oriented yourself, built a structure, and created a file. Now, once you actually have items in your office, you've got to manage them. ls is how you look around and list your files. Add a -l to that, and you're going to see every single hidden detail in that room. If you want to step backwards out of a room, just use cd ... to move up one directory level. cp lets you copy files from a source to a destination, and you literally just toss in a -r if you're trying to copy a whole folder. mv is pretty clever. It acts as both a way to move files to a completely new location and a way to rename them. Finally, rm-file.txt permanently deletes a file, and rm-r does the exact same thing for entire folders. But seriously, be careful with that one, because in Linux, there is absolutely no recycle bin to save you from a typo. Keep this energetic pace up, and you've officially completed Level 1. Section 3. Reading and editing files. Level 2. Peering inside. So we've built the cabinet, we made the files, but now we need to look at and modify the data actually living inside them. For reading, you've got a few options depending on the sheer size of the file. catfile.txt is awesome for small items. It basically just blasts the full contents straight into your terminal. But if you're dealing with a massive document, you really don't want to flood your screen. So instead, you use lessfile.txt to view it safely, page by page. You just press Q when you want to exit. If you only care about the very beginning of a document, head-n 10 will show you just the first 10 lines. And when you need to actually roll up your sleeves and write or change the text, nano-file.txt opens up a wonderfully simple command line text editor right there in your window. But the absolute most crucial point here is knowing how to find things quickly. You might be wondering, why use grep? Because honestly, searching a 10,000-line server log file manually with your own eyes is an absolute nightmare. Grep, followed by your keyword and the file name, will instantly hunt down and highlight exactly the lines of text you need, completely ignoring everything else. It is a massive, massive time saver. Section 4. Taking system control. Level 3. Gaining authority. All right, we are now transitioning from simple file management to actual, real-deal system administration. At this level, you need the ultimate passkey, and that is sudo. This stands for super user do, and it isn't just a command, it's honestly a temporary superpower that executes your instructions with complete administrative or root privileges. When you drop sudo in front of a command, you have absolute control over the machine, which means, of course, it requires a great deal of responsibility. With this newfound authority, you can use chmod 755 to dictate exactly who has permission to read, write, or execute a file. You can also check the vital signs of your machine. uname-a gives you the full system and kernel identity. df-h checks your available disk space in human-readable sizes like megabytes and gigabytes, while free-h does the exact same thing for your available RAM. If you want to see the beating heart of the system, top, or its cousin htop, displays all active system processes in real time. It's essentially acting as your server's stethoscope. And hey, when your screen inevitably gets too cluttered with all this power, just type clear to wipe the interface completely clean. Section 5. Advanced Network Diagnostics. Level 4. The final boss. Now, what's really interesting here is that this brings us to our heaviest, most advanced content yet, the final boss of the Linux terminal. Let's build our understanding by comparing two absolutely essential tools, SS and lsof. SS, which stands for Socket Statistics, is the modern replacement for the old netstat tool. It looks at the socket state directly from kernel space, which means it is incredibly fast and focuses heavily on the networking stock itself. On the flip side, lsof stands for List Open Files. Remember, in Linux, literally everything is treated as a file, and that includes network connections. lsof comes at things from the application side, looking at which system processes and file descriptors are holding those network sockets open. Let's look a little closer at socket statistics. ss-tulp is a command you're going to find yourself using constantly. It lists all listening TCP and UDP ports, and super importantly, it shows the process IDs attached to them. This is crucial because if a rogue program is taking up a port, you need that ID to shut it down. If you just want a really quick overview of what your machine is up to, SSS gives you a high-level summary of active connections. You can also filter down to just the connections that are actively connected right now using SST state established, or trace exactly what your machine is communicating with by filtering for a specific target IP using DST and the IP address. Basically, it gives you a highly detailed snapshot of what your machine is talking to at this exact moment. Now, when you see a weird connection in SSS and you really want to know who is responsible, lsof steps in like your lead detective. lsof-i/80 will hunt down the exact process ID that's holding port 80 open. You can ask it to list only processes actively listening on TCP, or even restrict the view to just IPv4 network connections using -i4. And if you already know a suspicious process ID, you can use -p with that PID, add an I, and it'll show every single open network socket belonging to that specific application. It's amazing. It links the invisible network activity perfectly back to the culprit process. But sometimes simply knowing the connection exists isn't enough. You need to see the actual data. Enter TCP dump. It's a packet analyzer, and it is the ultimate tool. It captures and inspects the raw traffic passing through your system's network interfaces. It allows you to literally see the raw data flying through the invisible wires of your network. Now, don't worry about memorizing all of these flags right away. Just try to understand the sheer capability you have here. Using TCP dump, you can target a specific network interface, like ETH0, with -i ETH0 to capture live packets. If you only care about secure web traffic, -i any port 443 captures HTTPS traffic across all your system interfaces. You can be incredibly methodical here. For instance, using -nn-c100 src host 10.0.0.5 will capture exactly 100 packets originating from that specific host IP without even bothering to resolve names, which keeps it lightning fast. And if the data is just too complex to read in the terminal, you can write it out to a file using -w capture.pcop and open it later in a graphical tool like Wireshark, or just read it back into the terminal later with the -r flag. Finally, we move all the way up to the application layer with curl. Now, most people think of curl simply as a way to download files from the internet, but it's actually an HTTP diagnostic powerhouse. It's used to test connectivity, inspect server response headers, and rigorously benchmark endpoint latencies. So instead of downloading a whole web page, curl-i will fetch just the HTTP headers, which is absolutely perfect for quickly checking a site's status code. Curl-v turns on verbose mode, giving you a granular look at the DNS lookup, the TLS handshake, and all the headers being passed back and forth. You can even force your request to route through a proxy using the X flag. But most impressively, using the W flag with a custom format file while silencing the output with S and O/dev/null turns a simple web request into a granular performance benchmark. It measures the exact milliseconds it took for DNS resolution, the TCP connection, and for the very first byte of data to arrive. And this brilliantly illustrates how all these advanced tools fit perfectly together. Consider this your ultimate summary cheat sheet for conquering the final boss of networking. We have SS targeting the kernel sockets to check port availability. We have LSF looking at file descriptors to link those ports back to system processes. We have TCP dump sitting right at the network interface to inspect the raw IP packets themselves. And we cap it all off with curl at the application layer, testing the actual HTTP responses and connection timings. Look at what we've done. We have completely bypassed the graphical interface, confidently navigated the file system, taken full administrative control, and diagnosed the network right down to the raw packets. You now possess the tools and the mastery to command the Linux terminal with true authority. So the only question left is, you have the commands, what will you build next? Get out there, open your terminal, and start exploring.